We have lesson here, it's 6.2, which is radicals and rational exponents. So we're going to talk about roots and what this is. So let's go back to thinking about this lesson where we talked about 2 to the third power, which we know is 2 times 2 times 2, which is 8. Okay? What we have with regard to the operations, we have multiplication, division, addition, subtraction, and with multiplication being a shortcut for addition, we found that this right here, these exponents, this was a shortcut for multiplication, right? A shorthand way to do this. Now, the way that division undoes, right? It's the sister operation. It's the inverse operation, if you will, of multiplication. You get that for addition being the inverse of subtraction. The same thing exists here. Now, many of you are familiar with square roots, but we're going to take here the third root of 8, which means typically when you see this, that you guys see this little shelf on the radicand and it's left empty. When that's the case, that's considered to be a square root. That's what's implied. But that shelf can be filled with whatever number. And this here is what we call the third root, or it also has a nickname of being the cube root. After the second power square, right? And the third power is cubed. We don't have any other names to give these. So what we have here is the third root of 8. In other words, what to the third power will give you 8? And that, of course, we already know is 2, all right? Think about this. Of course, if you guys have the square root of 16, right? What's implied there is the square root of 16. So you've probably memorized is 4, right? It's saying that what to the second power is equal to 16. And of course, in this case, that's 4. Now, other shorthand ways to do this. We can imply the cube root or any root by using a fractional exponent. So something having taken a third root is going to be the same as that to the 1/3 power, right? Versus when we had a to the negative 3, that was 1 over a to the third. That was a different thing. All right? The third root of a is going to be a to the 1/3. And what's nice about that is, let's say that we were going to say a to the third to the 1/3. Okay? Well, what that's saying is that's like saying the third root of a to the third. It's like undoing something that you just did. It's like times 2 divided by 2, right? You wind up with the initial thing that you had. In this case, that's just going to be the base. What we can do, though, is remember, when we have an exponent raised to the exponent, it means that we multiply. So 3 times 1/3 is 3 over 3. Well, in other words, this is just a to the first power, or just a. So as I said, undoing something that you started with, you're left with just that base, which in this case is just a. Let's do a few more exercises here. You're going to see the following problems in your homework. You'll see and be asked to find the indicated, find the indicated nth roots of a. First problem is going to be n to the, and like this is problem A. Okay, n to is going to be equal to 3, and a is going to be equal to negative 64. Okay, so in other words, the nth root here, what we're going to wind up doing is we're going to say that this is like negative 64 as being your base, and it's to the 1/3 power, right? That's the nth root, or the third root, since n is equal to 3, of negative 64. Okay, in this case, it is going to be negative 4, right? Because of the question here, remember what we're doing. We have, question mark. To some power, to the third power in this case, the nth power, is going to be equal to negative 64, in which case negative 4, right? Negative 4 times negative 4 times negative 4. So some of these we're going to have to do a little bit of guess and check as we solve these, okay? Let's do problem B. We're going to take the nth root, so the n root, or the second root, n is going to be equal to 2, and a is going to be equal to 81. This is a problem you're very familiar with, right? In other words, this guy is going to be 81 to the 1/2 power, right? That's your nth root. 2 is a square root, or a second root, of 81, which is going to be plus or minus 9. And here's why. Because you have to think of it, again, like this. Oops. Oh, what's going on here? You have to think about it like this. Something to the second power is equal to 81. What could go in there? And when we deal with squares, oh goodness. When dealing with square roots, we have to refer to both the positive and negative iterations. In other words, what could work there? What could you square? Well, think about this. 9 squared, or 9 times 9, that's going to be 81, but so will -9 times -9, which is also something identically multiplied by itself. So we have to account for that iteration. All right, let's do some practice. 4 problems here. Okay, problem the first, we want the 4th root of 81. Second, we want the negative 4th root of 81. Third, we want the 25 to the 1/2 power. And then we're also going to do D, which is going to be negative 25 to the 1/2 power. All right, let's see what we get here. In other words, this guy, again, this is the same thing as something to the 4th power is equal to 81, right? What is that something? Well, we have to do some experimentation. Now we know 9 times 9 is going to be 81, but that would be 9 squared, not 9 to the 4th. But we know that 9 is constructed by 3 squared, right? 3 times 3. So here, 3 times 3, right? Times 3 times 3 is going to be 81. Now, here's the way we consider this guy. This is the same thing as -1. That's multiplied times the 4th root of 81. And we already calculated the 4th root of 81, which is 3. So this guy is going to be -1 times 3, or -3. Straightforward on this guy. This is just the second root, or the square root of 25, which we should know that one. That guy's going to be 5. Versus, think about this. This guy's going to be the square root of -25, which is going to be this. It's going to be -1 times 25. Now, we can take the square root of 25, but not of -25. We can't take the square root of -1, right? What times what is going to result in -1? What times itself, in other words, what times itself is going to result in a negative? If you do it positive times a positive, right, identical to itself, or negative times a negative, it's identical to itself, it's going to always have a positive outcome. So since this can't really be done, we can't have a negative outcome, we can't have a negative when we multiply something times itself identically, we can't take a negative square root. So here, we're going to have no real solution. The solution, and make sure that you write the word real. That is critical. If you do not do that, you will not get full credit. You just write no solution, I will not give you full credit. The answer has to be that it's no real solution. And if you think like that word real is kind of silly, it's not. It has to do with the fact that, you know, the opposite of real, like reality, something that's imagined. Yeah, it's an imaginary solution, I promise you. That's what we're going to find out about in Algebra 2, actually. But we need to use the proper vocabulary now. We're going to evaluate 243 to the 2/5 power. All right, so here we go. What that means, we're going to take the 5th root of 243, and then we're going to square that. Okay? The 5th root of 243 winds up being, now we already did the 3 to the 4th was 81. If we multiply times 3 more, that's going to be 243. So that winds up being 3. 5th root of 243 winds up being 3. And that's going to be 3 squared. 3 squared being 9. something we're just going to be doing through trial and error. And again, kind of breaking this guy down. The reason that we got this is, again, this is like 243 raised, to the 1/5 raised to the second, right? Because 1/5 to the second is going to be 2/5, because we're going to multiply those exponents together. Next, we're going to evaluate 16 to the 3/2 power, okay? Well, how do we do that? Again, it's going to be 16 to the 1/2 raised to the third, which is, in other words, rad 16, the square root of 16 to the third, or 4 to the third, right? Square root of 16 is 4, and 4 to the third is going to be 64. So just taking you through my process, it might be quick, but that's how these guys are done. We have 9 to the 5/2, our last one of these today, in which we're going to have square root of 9 to the 5th, right? Because if we do 9 to the 1/2, it's going to be the square root. In other words, we have 3 to the 5th, and we already did that problem earlier, right? That was right up here, 3 to the 5th, which we heard was 243. I don't expect you to have these things memorized, 3 to the 5th and so forth. I want you to do your best, but you can figure it out. I mean, it's not something that's exceptionally difficult. 3 times 3, right? Times 3 is 27 times 3. That starts to get difficult, but if you did 27 times 3, you guys can do that by hand, right? Or once you have 81, you could do this next one by hand, right? So there you go. Gentlemen, that is all I've got for you today. Go ahead and get started on your homework on Canvas. Good luck.